So Bayes' theorem, which is probability of A given B is equal to probability of B, sorry, not B, probability of A times the probability of B given A, all of it divided by the probability of B. Now again, Bayes' theorem is very useful if you know one probability and you want to find another probability. For instance, let's say if you know probability of B given A, but you want to find out probability of A given B. Situations like this, okay? One basic problem is find the probability of having cancer given that someone tested positive, or find the probability of an email being spam given that it has certain words. So, or find the probability of success given that somebody has these characteristics. So conditional probabilities are very important. So we are going to do the breast cancer problem here again. So let's create the diagram. So somebody could have cancer. That's the event C. And event C prime is the complement that somebody does not have cancer. Somebody could test positive or somebody could test negative. Okay. In the problem, I don't like the wording of the problem. I'm thinking of changing the wording of the problem so that it's a bit more clearer. It not only confuses the students, it confuses me sometimes. I have to pay a little closer attention to the wording. So in the problem, they give you this. True positive is 90%. False positive is 15%. And let me explain this to you, what this means. True positive is when somebody has cancer and tests positive. That's true positive, okay? Somebody has cancer and tests positive. Now, false positive is when somebody does not have cancer but tests what? Positive. That's the false positive. Somebody does not have cancer but tests positive. So true positive. So I kind of want people to tell me, where is TP gonna be? I'm gonna draw another box here so that we don't use our original box. So this is cancer. This is cancer prime. That means it doesn't have it. This is positive. This is a complement negative. Which box is gonna be true positive box? Can somebody tell me? Which box out of these 4 boxes, which one is gonna be the true positive box?
Cancer.
Be positive.
Which would be which box? Tell me.
Top left.
Top left.
Exactly, thank you. True positive. Now somebody else, can you tell me which one is gonna be false positive?
Top right.
Top right.
Top right, false positive. Good. Which one is gonna be false? Oh, I did false. True negative.
Bottom left.
Bottom left.
True negative.
Bottom left.
What is it?
Bottom left.
Bottom left.
True negative.
Bottom left.
False negative.
Bottom right.
Okay. maybe I should clarify something here. If you have cancer, you're in this column, right? Okay. If you have cancer, you're in this column, right? Then if you test negative, is it a right answer or wrong answer?
Negative. Wrong answer.
Wrong answer. So
False
it's
negative is a positive, right?
false negative. Okay. It is a false negative because look, the person actually has cancer, but the result came out to be what? Negative, right?
Yeah.
And then on the other hand, the right one is going to be true negative because the person doesn't have cancer and the result came out to be negative. Is this clear? Or I confused you more?
Get it now? Yeah.
Is this clear?
Yes.
Okay.
Yes.
So this is going to be, that tell you in the problem, this is going to be 90% or 0.90. And they tell you this is going to be 15% or false positive, right? And this is going to be false negative or 10%. And this is going to be true negative, which is going to be 100 minus 15, 85%. Now, which boxes are correct? Which boxes are correct? True positive is correct, right? And true negative is correct, right? Then false positive is incorrect and false negative is incorrect. All right. So, any questions so far, anybody? Or did I confuse you with this table? Is everyone okay?
Yes.
Yes, okay, don't be shy to ask questions. All right, now what I'm gonna do, I'm gonna find the probability that someone has cancer given that the person tests positive, which is gonna be probability of having cancer times the probability of testing positive given that someone has cancer, all of it divided by the probability of testing positive. Now, let me fill in the blanks here. Probability of cancer given that someone tests positive is going to be probability of testing positive in the bottom, and the top probability of having cancer. They tell you probability that someone has cancer is 1%. Probability that someone doesn't have cancer is 99%. So probability of having cancer is going to be 0.01 times the probability of testing positive given that someone has cancer. Testing positive given that someone has cancer is 90% or 0.9. But we just need to find this value. Now, probability of testing positive is, by the way, probability. So testing positive is here, this row, top row, is when you have cancer and you test positive. That's this case, this box. Plus, you test positive and you do not have cancer. That means C prime positive. Okay. Now, probability of testing positive is going to be this thing plus this thing. But this thing is probability of cancer times the probability of positive given cancer plus this thing is going to be probability of no cancer times the probability of positive given no cancer. So probability of testing positive is going to be probability of cancer 0.01 times probability of testing positive when you have cancer, which is 0.9, plus probability of no cancer is 0.99 times the probability of testing positive when you have no cancer, which is 0.15. If you multiply and add these numbers, you get 0.1575. So this number at the bottom is going to be 0.1575, this, which is this, right? And on the top, you have 0.009. And if you simplify this number, you get 0.009 divided by 0.1575. That gives you approximately 0.057, or roughly about, I would say, 6% chance. There is about 6% chance that a person will have cancer, given that the person tested positive. Next is this. Probability of testing positive twice and having cancer. I mean, given that someone tests positive twice, what are the chances that he or she would have cancer? So let's go ahead and write this one out. I'm going to give you a new problem to work on. Find the probability that someone has cancer given that the person tests positive twice. So now this one is slightly interesting. This time, what you are doing, you still have to create a box that's easier to see. All right. So you have cancer, you do not have cancer, you test positive, you do not test positive, i.e. you test negative. And the percentages don't change. We just leave it as it is, 0.90, 0.15, 0.85, and 0.10. Now, for the second case where you test positive twice, what are the chances that you actually have cancer? Now, what is the value of C? Can anybody help me out? What is the value of C? What percentage of the population under consideration has cancer?
0.6.
1%.
0.1%.
Okay. Yeah, okay. I think few people wanted to talk. So let's see, one at a time. Go ahead. Yes,
Yeah, I was gonna say 10, but I agree it's 1 now. I see where.
you're gonna
was
say
wrong.
10. Why?
I was still under the impression that we had to say get the 0.90 and then get that and get 100 and subtract it by that.
Okay. Anybody else?
I had said 0.6, but I agree with 0.01 now.
0.6? Where did you get 0.6
Yeah,
from?
because I I was looking at the probability of having cancer, given that you test positive. I was looking at that for some reason.
Oh, you meant 0.06, not 0.6,
Yeah,
right?
0.06.
Okay. Who is it?
Luz.
Luz. Okay, Luz. Okay. Anybody else?
Is it 0.01? I think because it said 1% and that's equivalent to 0.01.
Yeah, okay. Anyone else? All right. Lose is correct. Okay. Lose is actually correct. Look, for you to test positive, don't you have to test, for you to test positive twice, don't you have to test positive once first? You have to, right? You cannot test positive twice unless you have already tested positive once. So the people that we are considering here who are testing positive twice is actually coming from the population of people who already have tested positive once. It is not the ordinary population anymore where there is a 1% chance of having cancer. It is actually 6% chance. Why? Because there is a 6% chance of having cancer if somebody tests positive. And we are considering the people who already tested positive. So this should be 0.06, and consequently C prime should be 1 minus 0.06 or 0.94. And that is the catch here. Okay. And these numbers, interior numbers of testing positive and negative, we are kind of assuming that they are staying the same. One could potentially argue, but we are saying that, okay, those numbers don't change. Is this clear? Why probability of having cancer is 6% versus 1%? 1% is in the general population, but when we are testing for the second time, we are not considering general population anymore. We are considering the population that has already tested positive. And in that population, if you already tested positive, what are the chances of having cancer? Which is 6%. That's why this C is 0.06 and C prime is 0.94. Now we have to do the same problem again. So this is gonna be, and there's a little bit of catch here. Catch is that this testing positive is actually testing positive for the second time. So now let's go ahead and write the formula. The probability of cancer times the probability of testing positive twice, given that the person has cancer, divided by the probability of testing positive twice. And probability of having cancer is 0.06 times the probability of testing positive, given the person has cancer, we are assuming that it's 0.9 still. And probability of testing positive twice. So it's gonna be this row, okay? This row, first row. So you can have cancer and test positive, which is 0.06 times 0.9, plus you can not have cancer, 0.94, and still test positive, which is 0.15. And if you do the math, let's see what you get. 0.06 times 0.9 divided by 0.06 times 0.9 plus 0.94 times 0.15, and that gives you about 27.69, about approximately 0.2769, or roughly I would say there is a 28% chance that a person that has tested positive, twice has about 28% chance of actually having cancer. That's what it is. Now you could extend it to the third time. So I'm gonna leave it up to you to work on the third time. So probability of having cancer, given that you test positive 3 times. I'm just gonna quickly draw the box here, okay? C prime, positive, negative, 0.9, 0.15, 0.1, and 0.85. What is C here? Can somebody tell me what should be the percentage of C? Huh?
0.28.
0.28, exactly 28%, 0.28. Then what is C prime gonna be? This C prime. What is C prime gonna be?
72.72.
1 minus 0.28 or 0.72, exactly. And then you do the same calculation again. Are you guys okay with it?
Yes.
All right. Any question on this problem?
How did you get 72.72?
1 minus 0.28.
Oh, okay, I see now. Okay.
100% minus 28% is 72%, which is 0.7. All right. Okay, so that's all for this problem.